Previously, we have seen simple statements and negation, which has a single truth value. A simple statement can be simply true or false. It can be any statement, but not a question. Question is not statement. All statements are either true or false. For example, this is coffee is a simple statement. Let P be the variable that represent this statement. A variable can be any letter that can represent a statement, very much like a variable in algebra. Now the truth value of P could be true or false. Suppose it is true and the statement is correct, then negation of statement is false, which means that it is not coffee but something else. This is how negation works. The letter P is a prepositional variable, and we can have one prepositional variable for each statement. You can use any letter instead of P, it does not matter. For example, it is raining today can be P, I will not go to school can be Q. So from now on we can use the variables to perform logical operation instead of using the actual statement. It is easier to use the variables. So each variable is one statement with a truth value, but we can create compound statement with multiple variables. So any statement with two or more variables is compound statement. The truth value of compound statement is combination of all the truth value of its prepositional variables. Take for example the two variables P and Q. It is possible that P could be true or false. It is also possible that Q could be true or false. Therefore, the truth value of a compound statement depends on what was the truth value of P and Q at that moment. Therefore, all outcomes of compound statement can be shown in a table form called truth table, about which we will discuss later. There are 5 types of connectives which combine simple statements into compound statement. Commonly we know them as or, and, if then, if and only if, not, in which or, and, if then, and if and only if are binary connectives because they need two or more variables to make a compound statement. The not is a unary connective called negation, about which you already learned in the previous video. Suppose we have two variables P and Q and we make compound statement using each connective. The first one is read as P or Q and the symbol is called disjunction. The second is read as P and Q and the symbol is called conjunction. The third is read as P implies Q and the symbol is called implication. The fourth is read as P if and only if Q is the symbol called biconditional. When is compound statement true considering each connective? Suppose P and Q makes compound statement using each connective, then specific truth values of P and Q makes the compound statement true for each connective. P or Q is true when truth value of one of the variable from P, Q is true or both P and Q are true. P and Q is true when truth value of both P and Q is true. All other cases are false. P implies Q is true when P is false and Q is true, or both P, Q are true. P if and only if Q is true when P and Q are true or both are false. So negation of P is true when P is false. So let us discuss the working of each connective in detail to understand the outcomes. Disjunction is or has two cases when the compound statement become true. Let's take two simple statements. P and Q. Let P be I am sick today and Q be the statement I will not go to school today. P or Q is the compound statement I am sick today or I will not go to school today. Let's say that the statement can be true or false independently. Any one statement is true, then it is not a lie and the result of compound statement P or Q is true. So I may be sick but I still go to school, or I may not be sick but I still skip the school today. The end result is that one true statement in the compound statement make the whole compound statement P or Q true. Even when both statements are true, makes it true. So we have different truth value for statement P and statement Q. The truth table for disjunction shows all input combination of P and Q and the result. In the first column, you list truth values for P, and in the second column, you list values for Q, and the third column represent your compound statement. The number of rows depends on the number of variables in the compound statement. We have two variables P and Q, therefore 2 to the power of 2 is equal to 4 rows in the truth table. Write down all the input combinations. T represent true and F represent false. Now from the table you can see that disjunction is true if any P or Q is true or both. The conjunction is true when both atomic statements P and Q are true. Using our previous example of P and Q is the statement I am sick today and I am not going to school today. If any one of them is false, then the whole compound statement using conjunction becomes false. For this statement to be true, I must be sick and not go to school. It means truth value of individual statement P and Q must be true. We can create truth table for conjunction which shows output for all input combinations of P and Q. Since there are two variables, number of rows is 4. The truth table shows that only when both P and Q are true, the result is true and all other cases are false. The implication is something we make all the time in our daily lives. Given some information, we arrive at a conclusion suitable to us. Suppose P and Q are two statements, then P is called hypothesis and Q is called conclusion. So we can call P implies Q, but there is no relationship between PQ. Let P be the statement X is greater than 100 and Q be the statement X is even. The atomic statements can be true or false irrespective of the if-then relationship. So case 1 is P implies Q is true when both the individual statements PQ are true. And case 2 is suppose P is true but Q is false, meaning X is greater than 100 but it is not an even number. So this statement P implies Q is false in this case. Now the third case is when P is false, the conclusion Q could be true or false and we not make any claim about it. However, implication is a statement and must give some true or false value. Therefore, it is sufficient to say that if P is false, P implies Q is true regardless of the truth value of Q. The truth table for implication shows all the results. A biconditional statement is P if and only if Q. that extends the implication. It means P implies Q is similar to Q implies P. The result of such implication must be same for biconditional to be true. So if P implies Q is true, means Q implies P must be true, or P implies Q is false, means Q implies P must be false. Then biconditional statement is true, otherwise it is false. The truth table shows all the input combination for biconditional, and we can see that whenever input is same, the result is true.